Let us talk about join and subquery in Oracle. How we can use join and subquery. What are the different type of join supported by the sub in Oracle 11G, right? So let us understand here. A join is a query that combines rows from more than, I can say, two or more tables or views, right? So Oracle performs a join whenever multiple tables appear in the queries from clause. So if we write, like, let us say, just simply I write here, consider select star from item. Okay, I write here item. So here I'm just selecting one table here, right? But once I say comma, I say, what is the other, say item and sales table I have, suppose. Okay, now once we write this two table name in a from clause, then we can say it is a join stuff, right? So we can add more tables even. In this case, this join is unrestricted. This join is cross join because there is no condition. We are not having any where clause. Once we add some where clause and I say item dot item id and sales dot item id in a where clause, then it will display only the matching records from both tables. Then it is a restricted join, right? Natural join. A subquery answers multiple part questions. A subquery in the where clause of select statement is called a nested subquery. So let us have a more discussion on this. So what is join? What are the different type of joins and subquery? What is a correlated subquery? We'll talk about that. Okay. So let us understand first join. A join is a query that combines rows from two or more tables, views, or there is a materialized views, a snapshot of that. So Oracle performs a join whenever multiple tables appear in the queries from clause. Materialized view is like, if we create a view, if any changes happen, it will not reflect it. You have to say refresh, or you have to recreate the materialized view, right? The following are the requirements for the using joins. Normalization splits a complex table into multiple small tables, right? So we have a concept of normalizations where we decompose our bigger table or some complex table into smaller one. So since we have broken the table into smaller tables, later we realize that, oh, I need data from more than this table, more than one table. Then I need to do the join. So tables are joined temporarily using a table. Join strategy to produce a single resultant table for query purpose. As it is only for query purpose, data redundancy is completely avoided. So tables in a database can be related to each other with common keys like primary key and foreign key that we match in a where clause, and we get the common records or matching records. The purpose is to bind data together across table without repeating all of the data in the every table, right? Now the type of join we are having: equi join, non-equi join, outer join, and self join. Okay, equi join. Equi join defined as a join in which more than one table are joined together with the help of common column that exists in both the tables. And in this type of join, the relationship between the tables are specified in the where clause by using an equal symbol. So we are using some equal symbols here and we are specifying the conditions. So equi joins are also called simple joins, or we can say inner join. Okay, so what are the matching records? Let us say this is one table, another table. So whatever stuff we are having here, so common of both the table, right? This is the T1, this is the T2. So whatever the common guy here, it will come into the equi join or we can say simple join, inner join, or restricted join. But these are what? Non-matching records of the table 2. These are the non-matching of records in the table 1, right? So this is the right outer join, and this is the left outer join. Okay. So I'll discuss in details the left outer join and right outer join. Okay. Equi join, renaming or removing ambiguity. When more than one column joined and in one column exists in both the tables and the column needs to be displayed in the output, it must be preceded by the table name followed by a dot or period operator. Otherwise, an ambiguity will occur because SQL will not understand from which table the said column to display. So if the same column is matching in both table, you must prefix with table name that I want this column from this table. Okay. You can notice here, say we are having a loan number here. Okay. So we can take the reference here. We can take the reference here. It is the alias of the table, and this reference we can use in this loan, right? Loan dot product ID, comma loan number. I can say loan amount. So suppose the product ID is available in both table, in this table as well as in this table. But I want here the loan, a product ID should come from the loan table here, right? So we are saying loan dot product ID. You can notice this line. And then we are matching here, right? Product ID, product ID. So product ID from the product table and product ID from the loan table. So we are using here a dot operator, right? To differentiate the column that from which table it belongs, right? Equi join. The following are the characteristics of the table alias in Equi join. Should not be more than 30 characters long, but the shorter it is the better, right? The table alias should be substituted for the table name throughout the select statement. So we are using some alias. Valid only for the current select statement, should be meaningful. Okay. A non-equi join, it's almost like equi join, but the difference is what? Instead of writing equal to, we are using this kind of conditions. Okay. So the conditions other than equal will have a non-equi join. Okay. Outer join. This type of join returns all rows from one table and only those rows from secondary table where the join condition is met. Okay. Now there's a left and right outer join indicates which side of the join represents the complete set. The opposite side denoted by a plus is where null rows will be created. Okay. So the following are the type of outer join. Look at here, left outer join, means all the rows of the table left to the join condition will appear. So left outer means all the rows from the left table and matching records from the right table. If we talk about right outer join, so all the rows from the right table and matching records from the left table. Full outer means missing rows from both the table being joined. So all unmatched records. Okay. And here we are referring that product key equal to product key, we are giving plus, right? So right side I am using here. So we can say this is a right outer join. If I add plus here, I will say this is a left outer join, right? So this is the LabTouter join. Sorry, I think in the previous one it is a LabTouter join only. So all the records display from here, right? From this table, product table, and only the matching record will display from the right table. So this is the LabTouter join. Now, so here is one example. You can see this. Same I'm using here. So this is the lab table and right table. So I'll get matching records from the product key table, okay? Loan table only, and product table, all records, okay? Right outer join, you have noticed that in the right outer join, we are saying plus here, okay? So all the records from the loan table and only matching records from the product table get it displayed now. We can also use some kind of clause here, right join, right outer join on this table. So there's a operator, plus operator, and we can use some kind of clause also. You can see here. Here I'm using just clause, FullOuter Join. So we are selecting here the columns and the table, product table, another table, right? So FullOuter Join. This is the alias of product table. Another alias is here for this table. FullOuter Join with on this value. So we are specifying the condition here and we are doing FullOuter Join. Instead of this, just you can write left outer join, right outer join will work fine. Okay. Self join is always having join with the same table. If you are having the query like display the records of same, display the records of customer who are living the same city, display the students who are having the same marks, something kind of, if this kind of requirement you can use self join. The following are the facts here. When one row of one table is to be compared, one row of one table is to be compared with another row of the same table, then it is a self join case, right? Logical table needs to be created from the same table temporarily. The table on which the self join will be used appears twice in the from clause and is followed by table alias that qualify column names in the join condition, right? So you can see here I'm saying EMP even, EMP E2. Same table I'm using twice in the from clause, but I have a different alias. So I can say this is the one table getting created, it's a temporarily, which will help me to match. So even.ename works for e2.ename, employee and their manager. From this table where manager equal to EMP number. So the following query uses a self join to return the name of each employee along with the name of the employee's manager. So list out the employees whose manager is same. Okay. Next is the natural join. The natural join clause is based on all columns in the two tables that have the same name. It selects rows from the two tables that have equals values in all matched column. If the columns having the same names have different data types, then an error is returned. So we can write also the clause here where natural join, right, with this table. Okay. Now we understood that what is join here. Now next is the subquery. What is subquery here? Let us say I want to display all the item whose sales is more than 2000, something like that. So I can say here select star from item table, right? Where say item ID in. Now I can write again the another query, select item ID from sales table, okay, where amount is greater than 2000, like this. Look at here. One select is here, another select is at this place, right? There's another select here. So this query is a inner query. Inner query. Okay, inner query, not inner join. This query is a outer query, not outer join, right? Outer query. This guy will get evaluated first. So it will get all the item ID whose amount is greater than 2000, right? So I'll get a list of item ID here, say 259 something. Now it will match the item ID to and display the records. Match the item ID, display the records, right? So it is like this. So display the 4 records here. 4 items will get display. This is what we have a subquery. A subquery is a select statement that is nested within another select statement. The result of the inner one is passed as an argument to the outer one, right? So inner is passed to an argument to the outer one. You can place the subquery in a number of SQL statement. You can place in a where clause, you can place in a having clause and from clause, right? Bell. Guidelines for using subquery. A subquery must be enclosed in a parenthesis. I did remember. Place the subquery on the right side of the comparison conditions for readability. Subqueries may be single row. Subquery. Single row comparison operators can be used for example equal to, less than, greater than, and so on, right? Multiple row subquery. So you can use some kind of in, right? Just I have used in, remember. And you can use some, any, all operator we can use. So that will return the multiple rows. Like 4 rows was written in the previous example which I written on the board. In this case, it will just return the single row only, equal to whatever the equal to of this value, just return that, right? Another we can use exist. Instead of in, we can use here exist in the subquery here. So you can notice here I am using here salary equal to, right? And then again writing one select a statement here, right? Here we are writing exist. Means if this query is having records, then display this guys. Exist returns a value true if the subquery that follow it returns at least one row. So if this guy is returning at least one row, okay, this guy will get display. If it is not, then no records, you will get it. Any operator, you can use any operator here, greater than any, right? Like this. The any operator compares the main query with any of the values returned by the inner query. So let us say I am getting some amount. If that amount is matching here, and if this amount is greater than this, any of these three, okay, display that, right? We can use greater than all. So it should be greater than all the value. Compares a value to every value returned by the subquery. And if it is greater than all, then return the records. So greater than any, greater than all, you can use it here. Okay. Next is the correlated subquery. It is just opposite. In the correlated subquery, it is used for row by row processing. Each subquery is created once for every row of outer query. So get candidate row from outer query, execute inner query, alright, and then use value from inner query to qualify the disqualify the content, display it. Again, just pass it. So outer query is giving a record to inner query and then inner query validating and then saying okay, now return. So result is coming from the outer query. So for each and every outer query, the inner queries get executed. The only thing that if you are referring the outer query inside the this block, see here, I am using here, then it is a case of correlated subquery. Okay. Find all the loans having loan amount more than the average loan amount in this. Okay, this is the answer for that, right? Loan amount getter, selecting all the average and then displaying that. So what are the loan amount that is having more than average? Now correlated update, use a correlated subquery to update row in one table based on rows from the another table. So here we are using update, right? And inside that update I am using select clause here, right? So this is the update, correlated update. For each and every related, the query will record will pass to the select, retrieve and then update it. Similarly, we can have a correlated delete. So we need to pass, we can write here delete a statement, set this and then we can say select, right? Here we are saying select. So outer query is a delete query. So this is a delete, correlated delete query. Another stuff, we are having the hierarchical subquery. Using hierarchical queries, you can retrieve data based on the natural hierarchical relationship between the rows in a table. There are relationships between the tables, right? A relational database does not store records in a hierarchical ways even. Though, however, where a hierarchical relationship exists between the rows of single table, a process called tree walking enables the hierarchy to be constructed. A hierarchical query is a method of reporting in order and the branches of the tree. So in that we have to say select, and there are some column which we can select some expressions from the table where condition start with connect by prior conditions we can apply. So we have to use some label start with connected by prior, and we can generate one hierarchy of the records. So hierarchical query can be identified by the presence of connected by, connect by and start with clause. Label for each row written by a hierarchical query, the label pseudo column returns 1 for root row and 2 for child, like that. Start with, specify the root rows from the hierarchy where you want to start, whether you want to start with root or this clause is required for a true hierarchical query. Connect by, specify the columns in which the relationship prior between parent and child rows exist. So this clause is required for hierarchical query. Okay, you can say this example: select employee ID, last name, job ID, manager ID. Okay, from employees, start with employee ID 101, connect by prior manager ID equal to employee ID. So display manager ID. For this manager, these are the employee ID, right? For this manager, these are the employee ID. So we can create one hierarchy of the result set here. I mean, in result set we can display some hierarchy. So that's all about join and subquery and the hierarchical subquery and correlated subquery, right? Thank you.